Yes, sir. Now I request our Professor K. Prasad, Assistant Professor of Mechanical Engineering Department, Adi Shankara Deemed University, to introduce our speakers to the gathering. Sir, please.
Okay. Good evening to everyone. I am Mr. K. Prasad, Assistant Professor in the Department of Mechanical Engineering at Adi Shankara Deemed University, Gudur, Andhra Pradesh. We are honored to welcome Mr. Rahil Hussain, co-founder and director of Peak Inverts BESS, a company dedicated to innovate energy storage solutions that are reshaping India's renewable energy landscape. Mr. Hussain is an electrical engineering graduate from National Institute of Technology, Silchar. He began his career with Oracle's Energy Division, where he worked for 6 years on the global smart grid and energy optimization projects, gaining deep expertise in the distributed energy resource management system and advanced power system. His contribution and him recognition as the winner of the Oracle Global Energy Innovation Challenge for pioneering DERMS with integrated battery energy storage system solution. He also co-led India's first private sector deployment of BESS under the PPA/OPEX model, a milestone in the country's clean energy adoption energy. In 2023, he co-founded Peak Inverts BESS in collaboration with Thorian Energy Australia. He delivered scalable and cost-effective storage solution for industrial and renewable energy clients. He has also been instrumental in implementing peak saving strategies in the commercial and industrial sectors, and he is currently leading the design and strategy for 50 megawatt hour lithium iron phosphate energy storage project with Greenco, one of the India's largest renewable energy companies. With his unique blend of technical expertise and commercial acumen, Mr. Rahil Hussain is driving the mission of making battery energy storage system a cornerstones of India's clean energy transition. Let us extend a warm welcome to Mr. Rahil Hussain. On behalf of the organizers and all participants, I extend a very warm welcome to you, sir. Thank you.
Thank you, Mr. Deru. Yeah.
Sir, once again, I welcome you all on board. Over to you, sir, please.
Yeah. First of all, I would like to say very thank you to everyone who present here to understand about the BESS and its applications strategies and how we can implement this in C&I space. That is nothing but commercial and industrial, even for colleges and hostels as well. So yeah, without any delay, let's start my presentation then. Okay. Hope you can see my screen, right?
Yeah, it's visible, sir. Please.
Okay. So yeah, as a part of introduction, our company is a Peak Invert ESS, and we started with the assembly of LFP batteries, and we primarily focusing on our energy storage products. Even though we have multiple product range in power applications, those are nothing but vehicles and EVs. Apart from this, let's start with the subject now. So let's get deep down. So you all know, right? Like, what about the battery? I mean, where we typically use the batteries, and everybody knows it's EVs. And I just want to I just want to ask a question here. Like, anybody who knows the, applications of BESS or battery energy storage system in the industry? I mean, any answer would be great. Like, I'm asking, like, anyone in the discussion can throw a light here. Like, yeah. I just want this interaction to be very interactive. I mean, this instead of just as a lecture, I just want it to be much more interactive. That's why this question.
Participants can unmute your mic and speak. Otherwise, you can put your answers or questions in the chat box.
Yeah.
Good evening, sir.
Yeah.
Yes, sir. Yesterday, one of the speaker has hinted that battery storage has been installed to store the energy while at the daytime, and it is used in the night time.
Yeah. And can anyone explain what its implications on the grid? Like how positively it can affect the grid stability or whatever it may be, like related to grid. I mean, I'm not talking about as on the customer side. I'm talking about the grid at a large, like national grid or central grid, whatever it is. Yeah, Ritu Tomar backup power supply. Yes, definitely that will be an option. But I'm here to explain that about BESS, which is not confined to backup power supply. It is much more, much bigger than just backup. Yeah. Any answers? Like you can unmute and answer about it. Okay. Okay then. Can I go ahead? I think so.
Yes, sir. You can go ahead. At the end of the session, you can have a Q&A.
Sure. Sure. Okay. Okay. So first application use case is peak shifting. So what is peak shifting? Basically peak shifting is nothing but, like if you see the graph here, let's take a Tamil Nadu as a case. For suppose we have a 4 different slots. Okay. One is 6 a.m. to 10 a.m. as you can see in the graph, and 10 a.m. to 6 p.m. we call it as off peak solar hours, and 6 p.m. to 10 p.m. it's evening peak. So in Tamil Nadu EB tariff policy, we call this as C1, this is C4, this is C2, and nighttime it is C5. Okay. So with the solar now, we can only be able to fulfill this particular gap. Okay. That is nothing but solar gap. So government is providing multiple options to adjust this morning generated solar energy in the night consumption. But right now they are not allowing us to adjust that energy in these 2 slots. But it is part of promoting the solar and green energy. They are doing this kind of a push to adopt and improve the investments into their states. They're doing this right now, but it's not good for the grid. Why? Because whatever the excess energy that they are pushing here in this time, the SLDC, State Load Dispatch Center, they don't know how to, they sometimes, or even most of the times, they can't really redistribute the entire energy within the state. And there can be a lot of excess energy that's being populating into the grid. And what it causes? Obviously, it causes a heat losses, and it will reduce the lifetime of a grid or transmission lines, and much more losses. So in order to cover this, what we're trying to do here with help of BESS. So whatever the energy that's being generated here, extra energy, we are going to put it in the BESS, battery energy storage systems, and we are going to supply it in the C2 and C1 time. In this way, the government, the stress on the grid will be reduced, and it will also attract a lot of investment into the energy sector. And most importantly, it saves a lot of money for the industries and industries and commercial clients. Let's take an example. So here, grid power cost between 6 a.m. to 10 a.m. and 6 p.m. to 10 p.m., including taxes, it will cost you almost around 9.84 rupees. Okay. And in the off-peak hours, it will cost you around 7.88 rupees. Whereas solar costs you around 3.5 rupees. So there is a net saving of 6.84 rupees. And the landed cost of BESS comes at around 4.9 rupees, not more than that. And if we add up the storage, a charging cost, it just gives you 7.9 rupees per unit. So Basically, what we are doing is we are shifting the peak. We are basically smoothing out this peak to have the constant tariff, constant demand, and constant supply. This is for one particular client. For the whole state, discoms will do the same. As I said earlier, this excess solar energy they can't really redistribute over across the state using their existing discom or transmission infrastructure. So that's why there are large scale best tenders are coming up. Per state, at least a 1 gigawatt hour best storage is coming up, especially to smoothen out this peak curve. And the process of converting this graph, this duck graph, into a straight line is nothing but a peak shifting or peak smoothing. Yeah, this is what it is about the peak conversion. Let me share you. So yeah, this is what is nothing but peak shifting and how it can help. I mean, it obviously it is a there will be a lot of grid savings. Grid negative impacts can be cope up, and most importantly, savings for industries. And obviously, they can be able to reduce a 54 lakh ton per annum if they install just 50 megawatt or BESS with them. Because the solar will only cover up the solar hours, but not the night hours. But the large industries, heavily polluting industries like steel, manufacturing, and everything, they run in 3 different shifts. They run 24/7. So what's the option? BESS. BESS is the option. So this is one thing. And all this use case is for, I just want to present one use case for one of our clients. So this will help you understand how we design the BESS and what is the per landed per kilowatt hour tariff structure that we are arriving and all. So for one of our clients, we planned for 50 megawatt hour storage system. It is in Tamil Nadu itself. And from this, we are going to size the BESS in such a way that 80% of it will be utilized and 20% will be like theoretically we expand it or we oversize it by chance, not by chance. It is as a design system to cope up the losses, and there will be a concept called depth of discharge in the batteries. So at max, you can be able to do a 80% depth of discharge for the longer life cycles of the battery. Coming to our battery, we are able to do the 90% depth of discharge. We call it TOD, and system life is at 12 years. And per cycle, we are offering, in general, the landed storage cost is coming up around 4.9 rupee or 5 rupee per kilowatt hour per cycle. Yes, this is the peak shifting model. And whatever the process that we do, like what is power out? Now come to power arbitrage. So power arbitrage and power peak shifting, what is the main difference? Let's understand the power arbitrage at first. So peak shifting is nothing but a technical term that we are going to use to smoothen out this curve on the technical side. Now, okay, everything is good. Technically, we are balancing out. Then what about the commercial aspect to it? Like as electrical engineers, as electrical department, we all know in the power systems, we do the tariff calculation as a one chapter, right? Based upon the TOD, based upon the time of demand, we calculate that, and we include the transmission charges and etc. to effectively implement the financial strategy for a tariff, right? In the same way, the commercial aspect to the BESS is nothing but a power arbitrage. So here, if you can see, in the solar hours, price in the Indian Energy Exchange can drop below 1 rupee also, because there is no demand. Everybody is producing the solar power, and there is no demand for it. There is a huge supply. So as supply goes up and demand remains very low, then that causes a price drop. So here, whatever the time that you are seeing, 10 to 6, So at this time, the price really drops less than 1 rupee. If you can check it on IEX website, it really drops down to less than 1 rupee. And in the peak time, that is nothing but evening peak, 6 p.m. to 10 p.m. and even at around 11, 12 p.m., the price will touch 10 rupee even above. So what most of the industries are doing is they're buying the cheaper power, storing it in the battery, and when the power tariff is too high, 9.84 rupees, then they're going to use it in the peak time. That is a commercial aspect of it. So that effectively giving them 67% IRR. That means their investment that they're whatever they are doing, that can be returned back well within the 2 years, like less than 1.6, 1.7 years. That is a commercial aspect of it. Now let's come to injection losses. This is one more very big challenging problem. We call it clipping losses, injection losses. You know, you all know, right? In the solar, captive solar or in the rooftop solar, they in the Tamil Nadu or in the southern part of region, we have the 30%, 10 to 30% of excess DC that's being generated. Okay, so when they are planning, they would have planned the inverter capacity to accommodate only that part of the power that is generating. So whatever the extra power that's going in, the inverter will clip that power and only take some part of the power and store it in the, and send it, transmit it to the grid. So here, what we can do is we are essentially storing those clipping losses. Instead of pushing it to the grid, we store it inside the battery, and we can reuse that in the whenever we are in need. That is nothing but in the non-solar hours. So in most of the times when they are injecting to the power to the grid, there will be an injection losses. Whenever they tied up with the grid or SLDC or whatever that transmission department or distribution department, they will keenly monitor the dispatch or power injection into the grid. Typically, when the solar started, they would have allowed up to plus or minus 3% or 4%. Now it is reduced down to less than plus or minus 1.5%. They want a precise injection, plus or minus 1.5% as a upper and lower limits. So if the solar irradiation is more and there is more solar power generation, what would they do? There is no other option than sending it to the grid. And if they do inject more than 1.5% or less than 1.5% of the contracted MD or contracted demand, they will be penalized with 110, 120% of the additional penalty that they have to pay to the distribution department or transmission department. This is one of the key area, and the logic behind that and technicality behind that is grid can't handle more than the power than that what it is designed for, right? That will damage the transmission lines, that will have the heat losses, and that will reduce the lifetime of the whole transmission line. That's why we need BESS. That's why there is a huge demand for BESS. That's why government calling for gigawatt hour scale BESS on a larger scale. Yeah, typically it is same thing here again. Here, as we can do this, injection losses can happen every single hour or every 15-minute block. Basically, we are reutilizing BESS in multiple cycles in a single day, like 3 times or 4 times we are charging and discharging, charging and discharging. This will continue for 4 to 5 times, and this can help them to get their revenue much faster. Like well within the 5 months, they're going to get back their investment back in use case of injection losses. This is the use case that governments and distribution companies or discoms or transcos will follow on a very large scale. Yeah, these are some essential advantages that they are going to get. One is obviously, as I said, they are buying the cheaper power at off-peak time and storing it in the batteries and reusing it in the very peak time when the power tariff is too high to purchase. And yeah, this gonna effectively reduce their extra tariff that they are going to pay in the TOD2 or TOD1, those are nothing but C1 and C2. That's going to reduce, they're going to reduce their energy bills, especially in the peak time. Yeah, so this is going to improve their return on investment. This is going to be a huge bonus and profit in their balance sheets as well. And obviously, everybody knows it leads to sustainable growth. So this is nothing but a graph in-depth explanation. Like you can see the cost differential of, at solar hours, it's just three rupees. Here it is 9.5 rupees. We're basically storing here and discharging here. Again, if you have wind, then that is one more added advantage. We can reduce the injection losses or clipping losses, whatever the technical losses those are there. We can be able to cover that out with the best. Yes. So this is a typical single line diagram that you can see here. So there will be, these are two 5 megawatt hour containers and one 2.5 megawatt PCS. And this is a bus bar. We basically connect, batteries are nothing but DC blocks. We use the power converter systems to convert that to AC while charging, while discharging, and while charging, the power will be converted to DC again. And this will charge and this will discharge and will be passed out to the substation or grid or bus bar. Yeah. So this is a typical BESS 5 megawatt hour looks like. It will be in a 20 feet container. And these are some voltage parameters, power parameters, and weight that you could be able to see. These are some system parameters at a 5 megawatt hour scale. And these are the voltage range and all. I could be able to send this after this meeting. You can have a deep down into the technical parameters. Yeah, these are our company support that how we going to support the after sales and all. Yeah, and that's not as part of the discussion. Hope you enjoyed the slides and you understood the BESS and its typical applications. Yeah. Thank you. Any questions?
Is it the first part, sir, or
Yeah, this is the complete BESS implementation structure. Yeah, now you can go ahead and ask the questions.
forum is open for the questions?
Sir, what will be the fraction of battery energy storage required to minimize the cost? Because the tariff ranges from around 1 rupees to 10 rupees.
Yeah.
The peak hour. So, how much of fraction of energy need to be stored for optimum cost saving in balance with the investment?
So you can be able to save. For example, are you talking about the solar generated energy? Okay.
Yes, sir.
So typically there will be a 20% excess generation that happen in Tamil Nadu region. So we can be able to, for example, let's say 1 megawatt solar will be able to generate 4,000 units of power, right? So typical sizing with that solar is 25%. So that is nothing but for 1,000 unit storage we can plan. That is one thing. Or else typically best sizing, how it works is it works based upon the peak time. Like what is the demand for particular customer with respect to the consumption. That depends on the peak time consumption. Based on that, they can be able to store. For example, if their peak time has an additional 4,000 unit requirement, then we can plan an additional solar installation, 1 more megawatt, and that will generate 4,000 units. And we can store that 4,000 units and we can be able to deliver it in the peak time or night time when sun is not available.
Okay, thank you. What will be the life duration of the battery energy storage life duration?
Yeah, it will be around the 20 to our battery system. It depends upon the life cycles. So it takes almost 8,000 life cycles for a battery. It almost takes 8,000 life cycles, and it comes around 12 years if we are using it for 2 cycles.
years.
If it is only for 1 cycle, we can be able to deliver it almost for 20 years.
Okay, sir.
Yeah.
Because yeah, maybe in the car battery and all, it serves for only 4 to 5 years like that. So
Yeah.
is there any material depends is there for which will be lasting for 20 years and so on, or 12 years
Yeah.
like that?
It is a lithium iron phosphate battery, and we use a semi-solid state technology. Whatever the cars that you are seeing, no, we call it a power battery. We call it power cell. So typically, what we are doing is in the energy storage, we are going to use the energy storage grade cell. Okay. Here, what we are doing is we are able to use the battery at a 0.5 C rate. Like power to energy ratio will be at 0.5 C. That is to store the 4,000 units.
கேட்டேன் business முடிச்சானே இல்லைன்னா அப்புறம் மாதிரி அடுத்து
To store the 4,000 units, we have to give, we can be able to, at max, we can be able to give a 2,000 unit power. That is 2 megawatt power. Okay. So that means power to energy ratio should be less than 0.5 C. Whereas in vehicles, what happens is this power to energy ratio will be more than 1 C. Okay. So we need a faster charging, and when we every time we press the accelerator, the power dispatch will be more than 1 C or 2 C, like that. You know, like if you are going, if you want to go fast, every time you press the pedal, then power that is coming out from the battery will be much faster. Higher.
Oh, okay.
So that way, like based upon the at what C rate we are charging and discharging, that is a very important aspect in defining the power life cycles of the battery and how much lifetime of the battery as well. Yeah.
Thank you, sir. Thank you.
Yeah.
So one question we have in the chat box: what is the initial cost of battery installation? As per you, I understand that it will be covered in short period.
Yeah. So initial cost of battery installation will be around you can consider a 15,000 rupees per kilowatt hour. Okay. Including installation. 15,000 rupees per kilowatt hour plus GST.
So what is the major difference between that conventional lead acid and this lithium ion phosphate battery?
Yeah, it's a good question. So the primary difference between lead acid and LFP is, one is depth of discharge. As I told you, depth of discharge is, if we, for example, let's say you stored 1,000 units in a battery. So at a single time, at a single discharge, you can be able to restore, you can be able to discharge 900 units. You have to keep the 100 units inside the battery for the better life cycle of the battery. So whereas in the DOD, when it comes to DOD aspect with the lead acid batteries, you can be able to only take out 50% of the battery only to ensure a longer life. So for example, if you store 2,000 units at a single time, you can be able to use only the 1,000 unit storage capacity only. You cannot go more than that. That is one major drawback of lead acid batteries. And second thing is life cycles. Even though you do 50% of DOD, the life cycle of lead acid battery is just 3 years. Whereas LFP batteries, as I told, it can last up to 20 years. Shelf life is itself a 20-year life. And we are offering at almost 5 years of standard warranty and 15 years of extended warranty. That speaks about the stability, about the power, depth of discharge, and usability and versatility of the LFP over the lead acid batteries.
In terms of energy density, sir?
Energy density per kg, you can consider 100 watt hour. One second. It will be around, for every 5 kg, you can be able to store 1 kilowatt hour with respect when it comes to energy application. When it comes to power application, It can be for every kg, it will be almost a 200 watt hour per kg is what we can be able to see. Like depends upon the application type that you are seeing. And where when it comes to lead acid battery, obviously they are much more bulky, they are less energy dense.
Sir, and as per your presentation, I understood that we can store, we can use BESS, the battery energy storage,
Yeah.
during the what? We can use that for peak hour.
Yeah.
Okay, BESS we can use during the peak so that we can store the energy during non-peak hours. Am I right, sir?
Yeah.
What is the role of solar here? Whether we will store the energy through the grid or we can use the solar. By going solar, we can further reduce the energy cost from the solar, from the conventional grid. By going to solar.
Yeah. So the solar is what we have to, battery system is works better. You can expect a much more revenues with solar because solar cost is very, very cheaper. And in most of the, for example, if you take a home, if you take an individual industry, if you take an MSME, like smaller enterprise, they can't afford having an open access connection and have a more power, right? And even if you purchase an open access power, the even though it costs you 1 rupee or 1.5 rupee, that will cost you almost around similar to 2.53 rupees. That is nothing but a solar power generation cost. So yes, it can be, obviously it can be used with the grid, that is there. And if you'll be able to use it with the solar, that's much more cost effective and much more environmentally friendly and much more profitable in every sense. Can we use sodium batteries instead of lithium ion batteries? Yes, we can be able to use, and you can see them in very near future, and it is one of our R&D focus area now. So whereas in sodium ion batteries right now, the problem with it is it's not as efficient as lithium iron phosphate battery. It can be we can be able to do only 5,000 life cycles, and it's a bit costlier than lithium ion batteries in present date. But in coming days, it can come down, and those are the two primary reasons the people are moving towards the LFP. The primary reason behind it is lithium supply is more than the sodium ion batteries. That is the primary reason. And sodium batteries are cost better, much more expensive, and it offers a lesser life cycles. That's the reason. We can be able to use, no issues at all. Yeah.
So one more thing, sir. As per our discussion, we suggest to go with battery backup during the peak hours.
Yeah.
That battery can back it up with help of the grid itself. Am I right, sir?
Yeah. Yeah.
Non-peak hours, yes. Instead of that, why don't we go for solar installation with net metering concept? So, compared to net metering, what is the advantage over the BESS? What are the pros and cons compared to these two systems?
I understand. So when it comes to net metering, you can be able to do only what, like how many hours? Only they'll allow you to set up a rooftop only for 80% of the load. Like if you observe your bill, there will be a concept called MD, maximum demand charges. So MD, for example, let's say your college have a MD of 1 MVA or 1000 kVA, for suppose. You can be able to set up a rooftop solar only at 800 kVA. You can't go more than that. 80% of the sanction load is what you can do for you can go for a net metering concept, because in net metering it makes discoms very hard to adjust that with the existing demand and supply chain, right? So that causes an immense stress over the lines. So what large industries do is they have their own captive plant. So or else if you are having more, and let's say for suppose you have a MD of 1000 kVA and you install a rooftop of 800 kVA. 800 kVA will only cover you for the 4 hours. What about the, for example, if your working hours are 8 hours, like that's a typical normal scenario. That's why so yeah, So typically, like, like if you, for more than 4 hours, what you do, you can't do the net metering concept. Definitely you have to go for the BESS again, right? So if you have the constant load of 800 or 1000 kVA for 8 hours of time, then solar only covers for 4 hours. But for the rest hours, we have to install a separate solar system and get that energy stored, and we can be able to cover rest 4 hours or 8 hours or whatever the rest working hours may be. Yeah.
Economically, what you prefer, sir? What you suggest? Whether
Yeah.
having BES is better or going with solar system with net metering is better?
Solar system with net metering, it depends upon your consumption. If your consumption levels are for 4 hours for the 1000 kVA, then net metering is completely fine. You don't need to invest again into BESS. But if your load is 1000 kVA constant for more than 5 hours or 4 hours, it will maybe around 8 hours or 9 hours, then it's definitely be better to use the BSS, right? There is an additional saving over there.
So we have another question in the chat box.
Okay.
Lithium-ion batteries can catch fire due to overcharging, high temperature and improper charge.
Yes. So to deal with it, we'll be using multiple protection systems inside the BESS. One of the most important thing is to prevent, we call it thermal runaway. So to prevent this, we are going to use a liquid cooling system. We are going to use the ethanol as part of a liquid cooling circuitry. So which keeps the LFP cells at a stable temperature, 28 degrees Celsius, so that we can have a longer time period. We can have a longer life cycles and longer lifetime. That's the primary reason and a primary protection that we're going to take. And we also have the fire extinguisher as part of the container. Even though we pass through all the security checks, even though fire catches, the fire security alarm will start trigger, and it will have an automatic fire extinguishing system which kicks in to control the fire. So these are multiple protection systems that we're going to take care inside the BESS. Yeah.
And to my understanding, this lithium-ion battery is different from the lithium iron phosphate. Am I right, sir?
Exactly. Yeah, lithium-ion batteries, depending
And
upon.
of course, to my knowledge, the operating temperature of lithium iron phosphate is higher than that of the
Yes. So lithium iron.
Right?
Yes. So depending upon the composition, depending upon the technology we use the semi-solid state technology. Whereas EVs use the liquid technology, like it's not a solid. We use the cell as a liquid, semi-solid state technology. So depending upon the cell composition, cell manufacturing, we can be able to determine the rest of other components depending upon our usage. We go more towards the pure lithium applications in the power applications like vehicles, trucks, and all these, wherever the power applications are required. When it comes to standalone storage, for the energy storage and everything related to it, we come down more towards the LFP side. Yeah.
If anybody is having any other question, please let us know.
Yeah, I have one more presentation to. Does accurate load and generation forecasting is problem for peak shifting using BESS and how it manages load and generation is problems? Yeah. Typically, accurate load generation forecasting is not possible. But what we can do is at least we can be able to sense the like with the previous electricity bills and all, we can be able to get an understanding about what is the daily consumption and at what rate they are consuming the power. So based on that, we can be able to size the BESS and PCS, power converter system. According to that, we can size the power and energy rating and get this application done. Yeah, for load generation and forecasting, this is a very big subject again. This typically they're controlled by using a Siemens and lots of other software companies. We do have forecasting algorithms based upon the prehistoric data of the generation site and consumption site, based upon the very curated events. There can be a demand search, and all this demand analysis can be done through an AI by state load dispatch centers. There will be some existing predefined logics and algorithms, computer algorithms, which helps us in forecasting the details and forecasting the demand, and accordingly we can be able to plan the best sizing and best storage as well. Yeah, it's a typical problem that we face today. So it's not a new problem. We already have the solutions for it. We're going to use the same solutions here as well. Yeah, we do have a lot of forecasting algorithms. That's again a complete. There is one Siemens forecasting algorithm that we take, and we use a MDM meter to meter data management. I mean, there can be a lot of data sources, and there are specific algorithms to do that. And there is a Siemens algorithm, and there are other custom algorithms that made depending upon the state and country. You know, like for example, in India, whenever the Ganesh Chaturthi comes, there is a sudden spike in demand, right? Like everybody will pull one connection and try to get that to their Ganesh Mandapam and have their extra power connection, right? Like when Ganesh Chaturthi comes, there will be a power surge. And in the same way, if there is any football match, there can be a power surge in European countries, but not here. When we have IPL, there can be a power surge here, but not in European countries. So it depends upon state to state and region to region, and algorithms and their uh, thinking pattern will change depending upon region to region. So there is no fixed algorithm for it. It will be a behavioral pattern that needs to be adjusted with every single time. Yeah.
So you can move forward to the next presentation, sir.
Yes. Yeah. So now I'm going to discuss one more concept called DG set, DG replacement. So as you all know, everybody uses inverter, right? Home inverter that will be using in our homes. So what we'll be doing, like for a smaller capacities like 2 kilowatt or 3 kilowatt hour, that perfectly works well. What about the larger applications? It's impossible to have the to manage it with the lead acid batteries. Lead acid batteries, they are not powerful. They are not energy dense. They are not even cost effective if you take the landed cost of storage. So whereas BESS, we have BESS with the LFP technology, now this is possible. We can extend this home inverter concept to the industries as well. So industries, what they are doing right now to tackle this problem, they're using a DG set. So in DG, by using DG set, they can experience a 35 to 45 rupee per kilowatt hour to generate 1 kilowatt hour energy. Whereas LFP, they can be able to store. I mean, even they are charging their best with the EB connection. At max, they can be able to get 8 rupee per kilowatt hour. That's it. And if you compare that with the DG set savings, it will be 60-70% higher returns on investment if you compare it with the savings of savings of DG set. And obviously, everybody know there will be a diesel cost increase. Inflation on diesel will be at least at a 7 to 8% every single year. Even though the international crude oil prices decreases, governments won't decrease the diesel cost, right? Whereas power costs can come down with the much more renewable energy penetration. Solar panel cost can go down, so that solar energy price will go down, and there will be regular maintenance will be required for that. Whereas BSS is a system, no maintenance required. Like you must be seeing, right, with respect to EVs. If you're buying EVs, for example, let's say Ola, they don't even have a service center. Even there is something goes down, they pick up your vehicle and take it to their own like service center, and they just fix it and get it back. There is no oil change, such thing like oil change or grazing or some other things that we typically see it with the ICE engines, internal combustion engines. Here it's very minimal or even zero. at some times. Yeah. And coming to the fuel logistics, again, for diesel, you have to go to diesel, some DG petrol bunk, and you have to show your ID to get the diesel on separate tankers and get the diesel and fill it. It's a huge process. Maintenance crew should be there. Regular inspections have to be done. Fuel logistics are there. Best typically operates at a zero operation overhead after installation. Your grid will carry the power that you will be requiring. And obviously emissions part, everybody knows the DG set will produce carbon dioxide, nitrogen dioxide, and everything. And best is a zero emissions and fully environmentally friendly. And yeah, like it can be, as maintenance is there can be breakdowns, there can be oil change, fuel quality check. And in India, in northern part of India, there is a lot of malfunction with respect to DG. They mix up diesel with some other water or some other oil, and which makes a wear and tear much faster. And obviously the cost, again, DC generation cost per kilowatt hour goes up to 70-80 rupees also. So power is nothing but power is very quality with respect to grid. They can't alter it, they can't change it, everything is there. And typically the oil diesel cost depends upon the market volatility, whereas energy, it come down but it won't go up, right? And yeah, like noise pollution is there, and zero noise pollution typically ranges 10 to 15 years, and with decreasing efficiency over time. And here you can expect a lifespan of 20 years with a max degradation of 2.5% every year, not more than that. And if you're using it for one cycle, it will be 1.35% only. And there is no ROI, like you can expect ROI by using DG set. It only costs you losses with respect to your business functions. If you shut down a factory, if you shut down your industry, even for one day, and if you want to run that on DG set, just think about how much cost it may comes down to. And whereas BSS, we can use BSS in terms of cost saving also by using peak shaving application, and we can use it as a backup as an additional advantage, major additional advantage. So yeah, scaling its DigiSets is like it's very significant capex and opex, and we can basically add the modular batteries and connect in serial and parallel to meet specific energy and power requirements. Yeah, can be integrated with renewable sources, and this depends upon the supply chains. And in coming days, and even now, there is, everybody knows about ethanol blending, and there is a DZ vehicles complete ban. And as there is no demand, yeah, like you can like there can be regulatory hurdles for the DZ and the diesel or petrol, whatever the crude oil related products are there will be tightening of those projects, and they won't reduce the taxes on that. They just increase the tax on the DG set, and whatever the revenue concept, they invest into the BESS or solar projects to cover up their investments. So governments are doing that, and even industries are doing that. This is the one. And yeah, obviously carbon tax credits will be there. So you can basically trade them with the carbon tax bodies to essentially convert those points to money. It is something very similar to credit card Vantage points, right? You can convert that to your flight tickets, hotel tickets, etc. and all. And yeah, so like yeah, in the space requirements, it won't take acres and acres of land to just like solar to fulfill the requirements. It just uses the very basic space, maybe a 20 feet container of space at max to support for 2.5 megawatt by 5 megawatt hour application. Yeah, this is one thing. And a DG set is one more very keen advantage that people are looking into. So this is one more major advantage that we can talk about. Yes. Any questions on this particular topic now? Yeah, Palani, Chinna. Yes, that's what we are doing. No, like if you followed my, uh, I think that why can't we store during off peak? Yeah, like see, you can't really get the power from the grid at a very cheaper rate. Who will give you power at 1 rupee or 2 rupee? State board, they won't give you. So you need to be a specific, very large scale industry or commercial entity, in order to get that power through open access. There are sizing requirements, there are particular megawatt requirements. Only if you are crossing those kind of requirements, then only you are allowed to get the power from other states at a very, very cheaper rate. That's why solar is also important. Yeah. If battery management system fails, then risk of fire with lithium-ion battery. No, like see, battery management system, it typically what it do is basically we need to understand the BMS part. So BMS, what it does is it won't allow you to overcharge or over discharge, but it can't have a control over the external environment. So in order to support that, and obviously, yeah, over voltage or under voltage, like over voltage can cause a thermal runaway. Definitely, that is there. That is one of the aspect. So to cover up this, we have multiple security and protection techniques that we use. One of it is liquid cooling circuit to keep the temperatures at a optimal temperature. Even it crosses, there will be an alarm and fire, automatic fire extinguishing that we are going to use to control the fires as soon as possible. Yeah. Yeah. Uh, any other questions? And yeah, one more thing I want to cover. The thing is, we are typically using a aux power supply to power up this cooling structure. It's not on its own. Like basically, it's something like let's say in a fridge, there will be a liquid coolant or a liquid ammonia that is in past, but now we are using chlorofluorocarbon CFCs to absorb the heat and send it outside, right? Similar kind of cooling technology that we are going to use, but here the chemical composition will change. It's an ethanol based cooling liquid that we are going to use it to control the temperature of the battery. Yeah. Sir, can we use C5 rating tubular battery instead of lithium battery? No, even tubular batteries are nothing but lead acid batteries, and it won't give you such a long life at a at a such high DOD also, depth of discharge. Yes, guys. Any other questions? You can ask me like with respect to like even for like our topic is confined to BSS and its effective strategies towards the when grid is interacting with it. You can have an external questions just about the battery as well. I'm open to those kind of questions also. Is the everyone is cool? Like I can move to next topic. Like
Okay, sir. Kindly move into the next topic, please.
sorry.
So please move into the next topic, sir, please.
Okay. Okay. Yeah. Sure. Hold on. Just a second. So here I'm going to explain you the basic BSS structure so that you will be updated with how BESS really looks and what is the composition inside BSS. I can be able to explain that part. So yeah, like this is the we are going to see this 5 megawatt hour system in a 20 feet container. So let's see what it contains. So it will contain cells, then cells combined into modules, then modules combined to rack, then BMS system will be there. Then as I said, there will be a liquid cooling system inside it to control the thermal runaway and to prevent the BSS from catching fire. Yes, as we discussed earlier. So these are some best specifications for 5016 kilowatt hour. That is nothing but 5 megawatt hour container comes in 20 feet container. For that, we need to give auxiliary power, and that will be at 220 volt. You may ask, sir, BSS is a power storage system. How can we give auxiliary power? So that is to maintain that liquid cooling circulation in the batteries to maintain the correct 28 degree Celsius temperature. So that on the outside, even temperatures may reach from -20 to 60, the battery should be able to withstand. So to maintain this 25 degrees room temperature, we are going to use that liquid cooling. For that, we are going to have this auxiliary power. That will be at 45 kilowatt. And we are going to use the RS485 protocols and IP65 protocols for the communication of BMS and EMS, etc., etc., etc. This is typically a best structure. So here there will be a PCS. PCS is basically which converts AC to DC and DC to AC while discharging. So that this is typical structure of it. And through EMS, in EMS, through EMS, we can be able to see SOC, state of charge, how much it is charged, how much it is discharging per second, and how we are doing it, everything, etc. And coming to the make, these are our partners, XDLE. So for the cells, we are going to use XDLE cells, semi-solid state technology that we are going to use. And for the fire suppression and to keep the batteries at the right temperature, we are going to use the liquid cooling system. And these are the individual cell specifications. That is, one typical cell will weigh around 5 kg, 5.6 kg, and each cell will store 1.2 kilowatt hour. That is nothing but 3.2 volt into 314 Ah. So that is nothing but 1.2 kilowatt hour battery cell capacity that we're going to take. And though that cell will be packed like this to convert it into a module. Then those modules will be converted into these kind of racks. These racks will be kept inside the 20 feet container and pass the integrated liquid cool to keep the packs to cell level at a right temperature. And this is the BMS architecture for any electronic faculty that they want to check. They can have this, they can see these communication protocols and how they are balance the cells with respect to voltage, current, and etc. etc. These are some of our product certification statuses regarding cells, packs, racks, and container as a whole. Yeah. So yeah, we covered how best can it be interacted with the grid, what is the effective configuration, and how best can be used as a power backup at a very larger scale, very larger scale, and as a DG replacement scenario in both industries or any other uh, commercial entity. and we also covered the best internal structure, like how it looks and what it does and how we are going to integrate. I mean, at least at a high level. Yeah. So these are the topics that I covered, and I'm done with my presentation. Now I'm open to your questions.
Participants, forum is open for the questions. Sir, we have some questions in the chat box. Have they been answered, sir?
Yeah, all those will be, those were answered. Yes.
Yeah. Thank you. Any more questions from the participant side? Today, the complete session was all about the battery energy storage system, BESS, that is BESS, BESS, and the terminologies, challenges, other kind of stuff related to BESS. More and more about the electrical systems. So forum is open. Do you have any case study regarding the use of BESS?
Yeah, we do have case study. Do you want to look at like what exactly you're looking for? I mean,
case study of an industry where before BESS, what was the energy consumption or the tariff they have paid to the paid,
yeah,
and after the implementation, what was happened, what was the ROI expected, and what was the savings in terms of cost and all.
Sure. I'll
Yes,
show you.
more guys.
So you are seeing my screen, right? So this is the one of our client called DCW Limited. It's a Tamil Nadu based client. So before that, they used to pay almost 9.84 rupee for the grid in the peak time. Okay. Now they can be able to get the solar at, this is a EB price in the peak time. Solar will be at 3 rupees and storage cost will be at 4.5 rupees. And now they can be able to save 9.84 minus 7.5, which is almost 2.34 rupees is extra saving. And per cycle, how much they're saving, like 4.5 rupees is the storage cost. So they can be used it in 2 cycles. So this is the per cycle per kilowatt hour cost. This is the per day, how much they're saving. And with all these calculations, you can see the net IRR on their thing, like on their investment is 17%. If you take it like just at a bank cost, like it will be around, I mean, if you take 100% from the bank, then it will be around 47.75% as ROI, and like IRR will be much higher. Yeah. Like it all depends upon the financial structure that you're going to make. Like how effectively we can be able to reduce the cost, it depends on that.
That's right.
I'll show you one more use case also, where you can find everything at once. I'll show you this. So this is one more customer called RD Steel. Okay, we are planning to install 35 megawatt are there. Here, if you can see, the per unit storage cost is 4.5 and average storage cost is 5.15. And this is what? This is one thing. And if they consider EB cost with 2.5% inflation, this is what peak time cost that they are going to get. Now it is 9.513. Next year it will be 9. Already it became 9.84. Now, so it will be more than 2% actually, 2.5% actually. And solar degradation cost per unit is at, let's say, 2.5% as a standard degradation. You can see 2.5% increase every single year. And landed costs solar plus BESS is 7.5 and a 2.5% increment. And saving from electricity board bill, you can see these are the savings, and this is the saving percentage, almost 20 to 25% saving that they can expect. Yeah.
That's fine. Oh, okay, sir. So what is the minimum capacity with which you can you will suggest for the BESS industry?
Like we are starting with 215 kilowatt hour system, but it depends on application to application and demand pattern to pattern. Like how much we have to analyze the demand pattern, and then we can be able to suggest it. But we start from 215 kilowatt hour system.
Is there any thumb rule, sir? So is what the minimum capacity where we can go for BESS to give the better result, below which may not be.
Yeah, it is for the peak time. Like peak time is where you get the highest tariff. So that's where you can have the maximum saving. That is the thumb rule. And sizing of it will be typically 25% of your total consumption. Yeah.
Okay. So whatever the AI software you told, it will manage the power from grid as well as from the BESS based on the peak and non-peak also.
That can be automatically adjusted. Yes, that can be done.
Yeah. That's right. Is there any other questions from the past participants? Regarding the battery storage, PG and all, please come forward and can unmute your mic and you can figure out your question, or else you can put your questions in the chat box. We will be having our guest for another 5-10 minutes. So, do you have MOU with any academic institutions? Or will you, if we come forward and ask you to go for any MOU for regarding the knowledge exchange or R&D projects and all?
Yeah,
There is a possibility will be converted.
no, we did not make any kind of MOU. If you're interested, then we can be able to do that. I mean, sharing the use cases and edge cases. Maybe you can use it for your educational program. Yeah.
For exchanging the students for what energy audit and all. Do you conduct energy audit center if the customer needs?
Yeah, definitely. Like that is a part of assessment of energy BSS sizing and all. No? So that is an effective. We will do that. Yeah.
Yeah. In that case, can you go for MOU for exchanging the students so that you can also use them for during the energy audit programs?
Yeah,
and
we
so
can.
that the student can also have some hands-on knowledge.
Yeah. Yeah, we can be able to discuss that. Yeah, definitely. Yeah, we're open to that.
Okay, that's fine. And thank you. Do you have any past history in that, sir? Or,
No, we started off in 2023.
okay.
So we did not tie up with any kind of educational institute until now.
And you are only working with the lithium iron phosphate battery.
Yes.
Any questions? Any other questions? clear. Soon passing for local. Shortly, you will share the feedback form. Yeah.
Yeah. Is that
So thank you. I hope there is no more questions from the participant side.
okay?
And, so on behalf of the Department of Mechanical Engineering and Adi Shankara University, we thank you for making yourself available for this beautiful session and sharing your knowledge and expertise with all participants.
Yeah.
And
Thanks for calling me and having me as a guest and giving me this chance of delivering like best application scenarios. I mean, most of the like industry doesn't know about this. So like I really felt very pleasurable, to have this kind of discussion and to share the best knowledge with multiple people at the single time. Yeah.
sir, thank you. We are also very thankful to you. And further, we will definitely be having some collaboration with you as we discussed. We can go for some student exchange program to MOU, or we can exchange the students for internship and that. We will come for you. We will again come forward to you.
Sure.
Yeah. So that they will collaborate. And if you have any other R&D kind of projects, that if there is a possibility for a collaboration with an academic institution or the faculty members, please let us know.
Sure, definitely. Yeah.
And we can do collaboration and do it. Also.
Sure. Thank you.
Yeah.
I hope.
Thank you once again.
Yeah. It's a very good session. Thank you.
Thank you, sir. Have a good night.
Yeah. Good. Bye.